and then I'll go for a little bit too. So go for it, Will.
Yeah, so this talk is going to be about Camino's deployment of Conduit's product, and Charlie's going to kind of give a quick explanation of what the product is and kind of what it comes with to give everyone kind of a sense of the tool from the vendor end, and then I'm going to demonstrate how we're using it and some of kind of the unique things that that Camino is using our own data with the Conduit data streams.
Cool, right on. I'll chat through this for a few minutes. Will, thank you. I appreciate the ability to come here and talk for a few minutes. So thank you guys all for that, and Mindy and Kurt for getting this set up. You guys should all see my screen. Let me see if I can click this slide. Cool. You guys should see a slide now that shows just a little bit about it. I'm going to spend just a couple minutes. Essentially, Conduit Resources was born in the upstream sector. All was kind of first generated at Forest Oil. I actually worked with Mindy quite a while there at Forest Oil. Built a bunch of these products, realized that we could probably re-engineer them and sell them commercially out in the market. We started that about 6 years ago. We've got just under 100 companies out there. We got just under 10 staff and several hundred conduits running out there. Essentially what we do is we build data management software, and essentially what that allows our clients to do is to have a managed data warehouse with the critical data stores that are of interest to them. So when we first started out, we were really hyper-focused on subscription data. Think IHS. Back in the day, it was DI, RS, and Navport. Now it's all kind of consolidating down into a more consistent stream. Think Osberg. We also work now a lot with public data directly. So think BLM and EIA and other types of public entities. And we also work with proprietary data. We've done some with Will and such. Think your own production data, frac data, accounting data, lease data, and things like that. Ultimate goal is to get that all into a managed SQL Server environment. I'll kind of just mention that and show that here in a second. What that provides our clients is local data access. There was a really great article I read a few years ago related around data gravity. I'm sure you guys could look that up and see it, but it's a really unique kind of concept of having your data and the important pieces of that next to your analytical applications. And the closer it is to it, at least whether it's performance-wise and things like that, and the more of it is kind of the more powerful it becomes for you, just kind of like gravity, size, and closeness relationship to it. It is managed, so Conduit tends to manage that. What that ends up looking like for our clients essentially is they end up with a single-use application. This is called Launchpad. This basically provides our clients with access to all the critical managed data stores that they have. Within each of these, you're basically going to have access points, things like Spotfire, ArcGIS, Excel, our WellFinder app, all the documentation such related to it. And then for each one of those products, you would imagine you would have this managed database that comes with it. So if we come into SQL Server, and I'll just mention a couple of unique things about that, and maybe give you guys a couple, key takeaways. But each one of those conduits that we provide, each one of those products essentially shows up as a database within this system. So you'll see things like drilling info and Veris. We've really hyper-focused on SQL Server. We think it's affordable, it's efficient. We think it's enough overhead and maintenance for the kind of analytics that oil and gas needs to do. We are looking at branching out to other things that people are coming up with, things like Snowflake, things like Postgre. So we are branching out, but historically and currently, we're really centered on SQL Server, which most companies have. One of the kind of key piece to this whole thing is essentially providing all the tables and views for this. And I'll point out specifically, this discussion is a little bit about the mapping side of things, but we do provide several pre-built mapping solutions. So if you were to just kind of look into this, and one of the unique ways we've done this is essentially built out a table that has all of the geometries and geographies built in. Those are both for 2D and 3D representation. And what that allows our clients to do is to have this updated on a daily basis. We re-spatially index and do all this work to it so that our clients are available on day one to have this available to them through things like ArcGIS with all the data on there and things like that, through things like Spotfire and applications like Excel also. Each one of these tables also has subsequent views that we've built out, things around activity, analytics, our front-end WellFinder application, and the mapping data. So this allows kind of that instantaneous quick access to it. We update it daily. And I think overall, the idea of having kind of a centralized managed data warehouse is something a lot of companies are after. we provide an option for people to kind of outsource that concept so that we build all these data objects and they're allowed to go in and analyze and stuff from there. So Will at Camino, a great client with Conduit Resources, and they have several internal and kind of external different data stores that they've entrusted Conduit with. And kind of will kind of take it from there on how they're leveraging it. But obviously we have 100 clients and different kind of subsets of products, and they all kind of leverage it in different ways. But our goal, provide it kind of in a live fashion. So cool. I'll kind of leave it right there, Will. And I think maybe Mindy or someone can pass you access.
Yeah, I think I can just grab it right here.
Cool. Okay, cool. I think you got it, maybe. I think I'm not sharing anymore, at least. Cool, looks like you're up, so.
Perfect. Yeah, so Charlie, really appreciate you giving us kind of that rundown, and I think that background will really inform what I'm going to walk through here. So to start, this is kind of the design of Camino's deployment, and so we are leveraging SQL to help with. At Camino, we leverage SQL data warehouse. With the help of ArcGIS Enterprise. Various conduits come into our SQL environment, and then we visualize the data through our web map. At Camino, we utilize Conduit in many of our departments: engineering, geology, land, business development. We have workflows with Well Data Labs, PDS Energy, IHS, Enveris, Frac Focus, Spectrasize, P2. We have a kind of proprietary data loader, and then we also do stuff between some of our internal departments like accounting. And we're able to easily exchange data and products through the same database. So instead of transferring a bunch of Excel spreadsheets or something like that where things can get lost, everyone's kind of looking at the same source data. A lot of the data that comes into our system can be kind of looked at as is. So you're just looking at the original data source from Enveris or IHS, almost as if you were just pulling down like a spreadsheet from Interdeck from IHS, for instance. And then a lot of it is actually combining the data from those sources with kind of internal analysis. So this next image is just an example in ArcGIS of what I'm talking about. So Charlie mentioned that when you download, when Conduit sets up the databases on your system, it's in a SQL database, and they set it up with a bunch of views to begin with. And so if you wanted to just add one of those views into ArcMap to use it, it would look kind of like this. So these are the wellbore paths with surface hole and bottom hole locations. And then there's also another layer, that Spectrasize major events layer. And that layer are showing the magnitude of earthquakes that occurred near those wells. Right now, it's just kind of showing any seismic activity, but there's a time slider that you can actually activate to, for instance, see like the dates of when you were doing fracs or something like that. And then in this image, we're also combining a fault layer, which we are pulling in from Kingdom. And so that's kind of how that's like the most basic kind of cursory way that we would show this data. And this data set is evergreen, meaning that I don't actually go in and update it ever. It's continuously pulling off of the Enveris site every night. And so these wells are continuously updated without anyone at Camino actually having to go in and do anything. This is the same for our IHS data, et cetera, et cetera. Here is an example of Spotfire. And so here you're looking at thermal maturity windows with, again, that either Enveris or IHS wellbore layer. And what we tend to do at Camino is pull these layers into Arc, and then I put them into Spotfire as WMS layers. And that kind of allows us to keep consistent symbology between departments. We also hit the SQL database itself from Spotfire for some of the work we do. you can go both routes. The WMS layers are nice when symbology is important, and then you want to hit the database itself when you're actually trying to do analysis. So kind of why this is important. Camino is located, our asset is down in the scoop stack merge. We started off in 2017 with 30,000 acres, and today we're around 140,000. And so during this period, we obviously grew a lot, drilled a bunch of wells, and kind of as we've grown and operated more and more in different spots in the basin, we've really refined our learnings. And so this is a map of the thermal maturity of the area. Oklahoma has kind of a lot going on geologically. You have heavy oil on one side of the basin, dry gas on the other side of the basin. There's a big change as you kind of move across in a fairly small area. And so it's really important for us to be able to be dynamic in our assumptions about wells, what we think it's going to be like, and then when we actually get well results and we see that, we want to be able to update our thinking. I think if you had a more homogeneous play, this kind of work you could probably do quarterly or biannually. But for us, it's really important that we can do it on a well by well basis, or even as we're getting kind of results on a go forward. So a lot of these things change pretty quickly, and it's important to us to be able to have that analysis constantly done and accurate. So kind of one of the workflows that I'm going to go through that demonstrates how we're utilizing everything is how we're kind of combining GIS data with engineering analysis. And so that occurs through our type curve workflow. And so our type curves are kind of defined by our reservoir, our thermal maturity window, and then the area in the basin. And maturity windows are updated when we get in well results. The GIS layer is then edited and then sampled to individual well, and then the GIS layer is then updated, and then this is sampled to individual well locations provided by DI or IHS, and then the resultant data is then hit by various departments. So an example of kind of the combination of all this. So here is kind of that thermal maturity window zoomed in. And in this instance, I'm matching the maturity window to a fault. And so we got some new seismic data and combined with well results needed to move the actual phase window. And so I went in, manually edited the phase window in our kind of while talking with our engineers and geology team. And then after I made that edit, I then exported, or I then ran a tool which updated a feature class in SDE, and then I copy and pasted that into our SQL database. In our system, I like to kind of keep a cutout between some of the processes, so you could set them up so that you were live editing, but this is an easy way for me to separate things a little bit to make sure that things kind of don't get messed up. But so essentially what happens is I make the edit, I save it, and then I run the tool, and then it populates the attribute table. And so it'll say for each section where the section is in terms of tier, phase window, type curve area when we make these edits. Now, this data can then be available in Excel. So this is a screenshot of our land team's dashboard for our acres position. So instead of having to pass through a Excel spreadsheet, or if someone in the land department is saying, hey, I have a deal, I'm trying to figure out how much we're going to pay for leases, I need to know what tier this is in, what phase window, et cetera, for my analysis. What is it? I can just direct them to this spreadsheet where they can get the data themselves. And so here they're connecting to SQL. They're connecting to the specific view that I just updated. And when they hit refresh, it's going to change that specific section per the change that I made. So they're able to access this data on their own. This allows them to then build their pivot table for reporting, or like I said, an example, if they're trying to figure out what value to assign a specific lease, something like that, they can do it. So this kind of allows all of the teams at Camino to be working off of the same data without having to rely on passing forth a bunch of emails. Another example are some of our visual analysis. And so this example is an EUR bubble map. And these bubbles are, and kind of what goes into them, are defined by our engineering team. We work together to create a view. And then that view is taking, again, what Charlie said, the bottom hole location, which is in the SQL Spatial database. You pull that out, pull out API, and then you can pull out various other relevant fields for the engineering team. And then they create a view, which then I bring into Arc and then push to our web map, which in and of itself doesn't seem to be particularly interesting, except for the fact that this dynamically changes. So instead of us having to do this full analysis to create these EURs every time something changes or a new well is drilled or completed, this does it on its own. So when the data is updated at, I think, 4 a.m. from IHS, and a new well location's put in, and then a well is completed, new production data comes into the system, et cetera, all of the analysis that has been coded in happens on the back end, and then these EUR bubbles just change. So these EUR bubbles aren't what it looked like or what the EUR was, you know, when we did the analysis. It's what the EUR was as of 4 a.m. this morning. And so that kind of allows us to have constantly accurate data. This is kind of a snippet of the view that's built. And so I'll be honest, this specific code was done by Wade, who is one of our engineers. So if there's specific questions about it, I'm not going to be able to walk you through everything. But essentially, it's pulling different fields from the SQL spatial database, and it's combining them with various statements to define what needs to go into each attribute field, which then I can symbolize in Arc, or off of in Arc. Also, we can take that same view and it can be used to run analysis in Spotfire. So this is that same view that I'm making a bubble map for our web map. We're taking that same view and we're pulling it into Spotfire and using it to make this heat map. So this heat map is IP30 oil % of type curve. And so again, this map will change as we get new well results, but then it will also change when I update the GIS spatial layers. So when I'm changing what our thermal maturity windows are in our map, or if I need to create a new type curve area on the map, when I make those changes, it will update this map automatically. Wade doesn't need to go in and then, you know, manually change things. He opens up the project and it will look different. Let's see. So the first image is looking at the specific conduit databases. Charlie kind of showed these in the beginning. And then nightly, what it's showing right now are the jobs that are running into Aries. So let's see. The Aries databases are linked to Conduit and are linked via conduit connections to P2, Harmony, IHS, drilling info, and GIS. So similar to how we constructed that table for Spotfire, this is constructing a similar product for Aries. So that way Aries has the same kind of connections. GIS is kind of providing that spatial component, while IHS and Veris are providing the pertinent well information and monthly production numbers. So now this is, as Charlie alluded to, we have kind of a in-house workflow that Conduit has helped us build into that same SQL database, and that's with Harmony. So we have a Conduit loader that runs hourly and provides constant communication between Camino and the staff at the flowback hands office. Every hour, spreadsheets are received by email and automatically loaded and archived into an hourly flowback database. Harmony is then updated with this hourly data for wells and flowback. Updates to Harmony are performed using the Harmony import wizard in conjunction with the Windows task scheduler. From this data, sand face pressures are calculated. The newly calculated sand face pressures are then pushed into SQL and thereby into Spotfire and Excel for live well opening drawdown analysis. Wells are switched from hourly to daily updates via qualifier in the Aries master table. Once the flowback hands are pulled off the well, the hourly and calculated sand face pressures are archived into a SQL database. So this is the table in Harmony that we're talking about. And so we have the hourly data, the calculated sand face pressures over here. So basically a loader that's doing this for us, putting it all into our database, and then making it so that we can then use it for later analysis. So kind of in conclusion, Conduit's data warehouse solutions have kind of optimized Camino's workflows, and they've allowed us to communicate between all of our various departments. Data integrations are easily customized and allow us to build our own analysis into the products. Automation of data feeds allow immediate access to evergreen data coming from vendors, rig sites, and non-operated parties. I feel like I moved through a lot of this pretty quickly, so I figured there would be some questions. Somebody wants to start us off.
Thanks, Will. I thought maybe you and Charlie might be able to speak a little bit more about. There's one of the screens you showed was your somebody's SQL queries.
Yeah,
there were parameters in there. Sort of, they were generating their own pounds per foot, and that I know involves a lot of things about figuring out which 30-day volume and which total sand injected volume you pull. And I think that you and Conduit have worked together to kind of figure out how to have resources that are not confused. You're not doing here. I can see that you're not doing a max of multiple columns and trying to pull lots of things together. It's pretty organized at the start. I wonder if you could talk a little bit more about how you've brought so much data together in an organized way.
Yeah, so I mean, kind of speaking on it, not specific to this example, but to, in general, the benefits of using SQL Spatial. If you're looking at for instance, the IHS well data, like you would pull down from Interdeck, and it's going to have, hundreds of columns potentially, depending on what you use. With SQL Spatial, you can actually define the specific fields that you want up front. So it makes it really easy to say, these are the specific columns that I want to look at, some of them which are coming from IHS, a couple that are coming from DI, and then some that have the actual geometry, so where there's that bottom hole location. So that makes it really easy to organize your data so you don't have tons and tons of fields that you're not working with, which can be really confusing. So to some extent, Conduit does this when they prepare these views. They'll kind of go in and curate the relevant fields, and then you can hit that specific view. But also you can do it yourself really easy. So if I'm working on a specific project, I'll kind of go in and pull just the specific fields that I need. And that's kind of different, especially in ARC if you're working with SDE, because often that just comes in with tons and tons of different fields. I'm looking on your on the questions on the tab, and it says question about WMS. So WMS is web mapping service. and it is one of the ways that you can share spatial data with ArcGIS. So it contains the symbology and is can go between multiple different platforms. So you can view a WMS service in Petra, in Spotfire, and it's going to be exact. It's going to be specifically like the exact symbology. So that layer is going to have attributes, and it's going to look exactly the same in Arc on the web map as they are in Petra. It looks like there was a question from Matthew about how easy is it to change the WMS the service requested. It's super easy. I have an MXD that just has every single WMS in it. And then the way that it works with Spotfire is you just toggle on which specific ones you want. So if you have 10 different Spotfire users that all want one layer to look a little bit different, you can have all of those in kind of the same project, and you can say, okay, Kat likes her wells purple and Nick likes them green, and you can have them all in the same kind of project. And it from my standpoint as the manager, it makes it really easy for me to deal with, and then they can kind of have the service that they want.
Can you talk about what you've integrated a whole bunch of stuff together to be able to deliver these web maps as tools for people across the company to use? I think one of the ones that I think is just amazing is having an Excel table for land that's dynamically updated from a GIS map. But what was some of the hardest things for you to get connected, or things that you had to think differently about in order to get them to talk to each other?
Yeah, I mean, I think one of the big ones figuring it out was how to do workflows with multiple people kind of involved who aren't, we're obviously using GIS as a way of visualizing the data and kind of the window into that database for a lot of users. A lot of our users don't know how to code. A lot of them aren't going to use the database that way. And so we're kind of using the web map as a way to visualize that data. But one of the struggles at first was, okay, but how do we get a non-user to be able to interact with the data? Like, sure, they can see it, but they have valuable endpoints and insight that they need to put into our database. And so a good example of that is our COO, Seth Yurdy, is really hands-on, and he wants to be able to kind of put his thoughts to paper when it comes to where we're going to drill units. And so he wants to say, this is our near-term drill schedule. These are the specific units that I'm interested in, or this is where I think we're going to go over the next year. And he wants those to pop up on the web map. He wants everyone else to be able to see them. And he wants us to be able to do analysis off of those. And so in that specific instance, I created a bunch of different layers that he can edit on the web map. And so he's actually going in and drawing units in on our web map. Those are saved in a SDE layer in Arc, and then I'm actually pulling those into views. So, he'll be sitting on his computer in his office, he'll draw a unit, and then that'll immediately kick into our full analysis, and Wade, our engineer, is seeing them on his side. So it's kind of directly getting C-suite thoughts into the analysis instead of having to have it kind of be done at a meeting level when you have someone directing you to do it.
We had Matt Belbradich asked a question of what's something you might have changed if you were starting over again, knowing all the things you know now after having worked hard to put it together. What would you do differently?
I think one of the biggest kind of struggles is that the data's changed, and Inveris has bought up a ton of different companies, and Osberg's changed, and so I think now it would be a lot easier to do a lot of our processes because we actually started off with a bunch of kind of data sets that changed or weren't as good. And so I think what I would do differently is, really look at the environment and what data sources are available today and maybe change which conduits I picked or how we construct our analysis.
Charlie, do you have anything to add to that? Because you've seen a bunch of sort of the insides of a bunch of companies on how they're trying to connect things. You might have some ideas or concepts things you've seen that work, things that you have seen that we might expect to work that don't, and just general guidance for how getting connections really working most effectively happens.
Yeah, sure. I don't have probably a lot to add on that, although we could probably talk for incessantly for days on different strategies people have. We've always been under the premise of trying to do it simply and affordably, you know. So SQL servers always ring a bell for us. Microsoft Windows Server, kind of that platform has always seemed simple. You know, doing this 6 years, I've been oil and gas 15. One of the other things we've really seen kind of slow on its uptick is the cloud, right? We've really seen some people kind of back off that concept, and people are starting to realize that the cloud's kind of expensive. And we work in the cloud as well, so we don't really care long term. But you know, we've seen kind of a little bit of a slowdown in the desire. You know, it was a really hot topic for a while. Everyone's got to go to the cloud. Big companies are spending millions of dollars to transition, plus the money they're going to spend monthly in the cloud. So I think I've seen a little bit of a kind of step back from that a little bit. You know, just kind of that cloud instance. SQL Server has always been a big piece to what we do. We think that's a really efficient kind of system to manage all these different data stores. So,
Brian, as far as Spotfire, yes, everything is in Spotfire and WGS 1984, but the actual data sets aren't necessarily. So when I export the WMS layer, I specify the projection. And so ARC converts it for Spotfire.
Yeah, Spotfire projections are fun.
Yeah, that definitely took some figuring out. I would say also, if I was doing everything from scratch or could bend people to my will, I would say use Kingdom and not Petra. Kingdom plays with all of these kind of new technologies a lot better. I wish geologists didn't like to use Petra, but they do, and it's a pain, and we make it work. And there's certainly some kind of workarounds. Geographics is also, I've worked with it a bit too, and yeah, it plays a lot better than Petra. So either one of those options.
I think the world may be full solar by the time Petra's gone, is my guess. Those will probably come together.
Are you made? I didn't really catch on to that. I thought you were just using Kingdom, but are you dealing with some connections to Petra?
Yeah. So for Petra, we push layers in via WMS services, so Petra can look at those. And then we also kind of have some workflows pulling data in and out of Petra, but a lot of times it requires like a one-off step for some of the stuff we want to do. I mean, you can access the like conduit layers via Petra, but some of the specific analysis you have to still kind of load the data in. One of the things that we kind of figured out is, so obviously for Oklahoma, because of forced pooling, we're relying on sections to kind of sample the whole area in order to do some of this analysis. So for like Petra, we fake loaded in all of the center points of the sections for Oklahoma in as wells, and then tied a bunch of our analysis to that spot. So that way we could kind of fake create a lot of these like IRR maps and stuff like that in Petra.
That's really interesting.
Yeah. Hey, Kurt, I got one other kind of comment I was going to mention before. Hopefully I wasn't on mute the whole time. I think I was on mute for some, so my apologies. One other thing I was going to mention, kind of your point of like, you know, what would we do differently, or what we recommend for clients and stuff or other oil and gas operators, is to be really deliberate with what you're trying to obtain from data management tasks. You know, where we see not necessarily failures, but kind of is where there's a lack of goals, right? I want to master all the data, right? Well, as Will mentioned, as everyone knows, there's like thousands of attributes for IHS. You're collecting hundreds or thousands internally. There's other data stores. You have certain apps that are collecting them. So what we've seen as kind of a where we've seen maybe some people not as excited or not as happy with the results is when they're trying to master everything. Our recommendation is just be very deliberate with, we see great success working with, folks like Camino and other clients where they're like, we want, our proprietary production data in Aries. We want a separate Aries project stood up with IHS data. Maybe we want some sort of blend between IHS and DI, but it's very deliberate in how they want to master the data and not necessarily look at it in a holistic fashion, but a very focused manner of like, we want to master, these data sets to go into these applications for these reasons. And we think stepping into it that way seems to be a little bit more efficient than trying to go and bite off the whole piece before you narrow down what you're actually after. So that was what I was going to add. I'm not sure if any of the other stuff came through earlier too. We'll see. I'm sure someone would have said something. I was rambling for a while, so.
I mean, I think it's a really good point. It's one of the things we get wrong a lot of times is forgetting that the point of all this information is to make a decision for the company. And so finding a way to focus on the decision tool and then route the data into it. And I think that's what's one of the things that, to me, of all the work that you showed, Will, the land spreadsheet that's building off of all the different subsurface work that's going into it and reading sort of live production information. That's just a remarkable thing to build, but it's very focused in what it's trying to do. I think it's a really good example of how to use integrated systems for a purpose.
Gosh, yeah.
Yeah, Matt is pointing out JSON and SQL. Well, I think does anybody else have a question or something, a comment they want to make? I know a lot of you are doing some work like this at your own companies, and whether it's grand scale stuff, integrating as many systems as Will has worked on, or just connecting, Petra data to Spotfire. Does anybody want to say anything about what they've found works and doesn't? Well,
Kurt, I think a blanket request to vendors would be, can you stop making your own web maps for your data that you make everybody use? Like, nothing drives me crazier than the fact that IHS, Interdex, B3, Osberg, it's like I have 15 web maps that everyone wants me to use, and they want me to load my leasehold picture in, and they want me to load my unit layer in, and then they want me to use 15 different web maps every day in my workflow. I'm like, of course I'm not going to do that. Focus on putting a good API out that I can pull all of your data in and organize it. Like, why would I want to give you my proprietary data when you're the data vendor and I'm the operator? That whole thing has just always blown my mind. And a lot of companies kind of, will work with Conduit and, have a good relationship and understand our workflows and what we need to do. And that's great. But there's a couple people that I have emails from them that I've just stopped responding to because they're like, oh yeah, your data subscription is this amount for what you want, but if you don't use our web map, it's 5 times more expensive. And then they want me to continue on the relationship with them. I'm like, I'm not going to use your data anymore because I'm not going to go onto that web map, and that's the only way that I can look at a water well. If you want me to be a good customer, you need to provide it in a format that I can utilize.
Yeah, I think that there's a lot there that I think that's one of the fun things all of us are struggling with is when you get put into somebody's limited calculation box and you can't do a volumetric assessment over a location, spatial polygon, and an integral across a time series, you're stuck. And if they want you to live in their box, you're limited in the tools you can use. And we're all trying to figure out how to build our own because the ones that exist aren't good enough. Well, I think I see a lot of people agree with you. We're all kind of running into the same kind of problem there. Will and Charlie, I really want to thank you guys for taking time to put this together and to talk to us about what you're doing. Hopefully we can keep the conversations going in the future and get some in-person events happening and get people talking about what they're doing over a beer in the near future. I don't think we have anything set up for the next talk, but we'll get something going. As ever, if you have people that you want to see talk, subjects that you're really interested in, things you think we can be exploring more with the group, please make suggestions. Look forward to seeing you again next time and seeing you around Denver. Thanks, Will and Charlie, and I'll see everyone else next time.
Cool. Thanks, everybody.
Thanks, Kurt. Thanks, everybody.
All right. See ya.